So this unit on logical reasoning works a little differently than the other units in this course in that you're not going to be asked to do a homework assignment or a test, and these are not going to be on the exam. You have undoubtedly used logical reasoning and mathematical logical reasoning through the rest of this course, but this unit will give us a chance to introduce ourselves to the language of mathematical logical reasoning and hopefully allow you to do some things that you're already pretty good at. So we're going to work through this. You will hand in the notes completed. The videos will go through the notes with you. And then at the end of the notes package, you'll notice that there are a number of puzzles. And your job is to pick 3 of those and solve them, hopefully solve them correctly, and write about your process of solving them. It's okay to make mistakes. You may want to use the glossary that's in this package as a bit of a prompt to help you use your words to explain what you're doing in solving those puzzles. In choosing the puzzles, I would encourage you to use the little video that gives you little hints and strategies about all of the puzzles because that might help you make a choice in choosing which ones you do. This unit's worth worth 10% of your final grade, and this is the rubric for how it's assessed. So always take a look back at this. If you have any questions, let us know. So let's get into 1.1. 1.1 is really just starting out with this idea of observing patterns and making conjectures. So making up rules that explain what's going on behind the scenes in these patterns. And you do this all the time. Now I've started with some visual patterns, some pictures, if you will. I love pictures. If I can figure out a math problem with pictures, that really puts me in my comfort zone. So the idea here is that you have this series of shapes, number 1, 2, 3, and 4, and it says find the 5th item in this series. Well, if I take a look at how many points each one of these has, I'd have 3, 4, 5, and 6. Well, this one's going to have 7 points on it, right? There's count to 7. Is that 6 and 7? All right, it's ugly, but there should be 7 points on this. So we know, and I can kind of formalize this. So item 1, 2, 3, 4, and 5. You may have just figured this out in a picture puzzle. That's totally fine. I'm going to give us some other tools in kind of documenting what we see. So the number of points would be 3, 4, 5, 6, and 7. This is what the question's asking us about. But it also says, and this is a little bit harder, mathematically, what would any item in the series be? And so if we could figure out the pattern of what's going on here, really what's happening behind the scene is the nth item will have 3 points plus whatever number n it is in the series minus 1. So I've given us the answer here, but let's check this. I'm saying that this is the rule. So let's check this for the 6th item. Just recognizing the pattern, it should be an 8 there. But let's try this. Let's sub 6 in for n. So the 6th item would be 3 plus 6 minus 1. And we're hoping that gets to 8, correct? And that's 8. And so we've come up with our rule. We observed our rule to get what's in the box here, and then we've tested our rule. So the fancy word for rule is a conjecture. Okay, let's try another one. Some of these you're going to be like, huh? And that's totally fine. You absolutely have strengths and skills in this. I'm not asking you to do everything. Yeah, so just kind of play along, if you will. So the next one says, this is our pattern. So we have items 1, 2, and 3. And it says here we're after the 5th item, right? So I could fill in the blanks. I could just figure this out in pictures. And honestly, that's my go-to strategy. So I'd have 4 boxes, right? Each one is stepping up by the number of boxes, and then each box has a triangle attached to it. So there's my 4th item. Oops, That's really ugly. And then my fifth item would have 5 boxes in it. 1, 2, 3, 4, 5. Pardon my really messy drawing. I'm sure yours are much nicer and neater. So, this is one way to figure out what's going on. So if I wanted to, I could totally figure out what's going on with the fifth item. If I were to do like I did before, and maybe this throws you, absolutely fine. Putting it in a chart, we have items 1, 2, 3, 4, and 5. And in this one, I have both squares and triangles, right? So whatever my n item is, that's the number of squares that I have. If you take a look through what I figured out, right? So the number of squares is really just whatever n is. The mathematical rule for the triangles, let's take a look. So the first one has 4, then we'd have 6, then I'd have 8, 10, and 12. So each time I'm going up by 2, right? You can see that. So each square adds 2. And so coming up with the number of triangles would be 2 plus 2n. Let's take a look at that. Let's test it on this fifth item because that's what we were really being asked about, right? Determine the fifth item. And then it says determine the nth item, right? So this is what I'm doing here. If we were to take number 5 and sub it in, we would get to our 12. And so this is our conjecture, and we have tested our conjecture. You've probably figured these out by just starting with, drawing it out. This is honestly the way that makes the most sense to me, but I'm asking us to push ourselves a little bit to entertain the idea of coming up with a mathematical model that we can apply to these patterns. All right, so let's get into a numbers pattern. I like the pictures much better than the numbers. I find that sometimes in these ones, I do better at making sense of it when I see a proposed idea. So in these ones, if I figure out the numbers in the series, this is my first, second, third, fourth, and fifth thing. The question's asking me about the seventh item. So I might go 6 and then 7 and see what I can do. So what this pattern is each time I'm adding 2. So that would give me a 12 and a 14, right? I've determined the seventh item in the series. And now for this harder part, mathematically defining the nth number. If I take a look at it, the nth number would be whatever my number is times 2. Let's just check that as our conjecture. So for the first one, I've got 2. For the second one, 2 times 2 would be 4. 3 times 2 would be 6. And this is our rule. This is the nth sort of item. That's defining my series here. The next one's a little bit harder. So we've got the numbers in the series, right? Again, we're trying to figure out the seventh item. So we can take a look. Each one is being multiplied by 2. So we'd have 96, and then we'd have 192, right? Multiplying by 2 each time. So I've gone and determined the seventh item in this series. That is my hope that you get to. If we were to define the nth item in this series, this is really hard. I'm going to go ahead and give it to us because I have to think about it each and every time. So I think that that's like above and beyond. It's really hard. Go ahead and test it though. See if I'm right. I actually caught a mistake when I was making this video on one of these. So I think I've got them right now. So to solve these, whether you solve them with pictures or, you were even testing my answers, you're using inductive reasoning. It's a kind of reasoning that allows us to arrive at a conclusion, a generalization, or an educated guess. It's what we do in science a lot. Where we get to our proposed explanation is a conjecture. And so, when you think you've come up with the rule, when you think you've come up with um, the mathematical model, that is a conjecture. And we were testing those conjectures. We did it to see if we were right or not. So in all these drawings are really, really useful. That's my preferred way. Tables can be helpful, but I do think that it's hard coming up with that nth item in the series. So take a look at it. Some of this unit's going to be hard. Some of it you're going to be like, wow, that was so easy. I don't know what the catch is. And all of our brains work differently on this. I really love doing this stuff in person. So do roll us in, like ask for help when you're doing this unit because it's, I think, super exciting. Anyway, okay, so let's take a look on these a little bit more. So we've got some picture ones, and I think these patterns are ones that I like because I can draw. So trying these ones, I would have, actually I'm going to just switch to my answer key for these ones because it's going to take me forever drawing them. So this is my ready-made answer key. So the top of the next page, you can see that I drew out my fourth and fifth item in the series, right? And then I also made a table listing out the number of the items, right? So the number, whatever n is in the series, and then the number of triangles that I counted in there. And so, sparing you my terrible drawings as I make these videos, we can take a look at these ones. And I've come up with a conjecture. I've come up with a rule for the number of triangles in whatever item I'm looking for. If we needed to figure out, I didn't put this in the answer key, the number of small triangles in the 10th figure, that would be 10 squared. I certainly wouldn't want to draw this, but in that item, in the 10th item in this series, there'd be 100 little triangles. And you can see how tedious it would be if you did have to draw all these out. Okay, so the next one, if we take a look at this, it starts out by giving us these triangles, and your notes aren't all filled in. So you can see the first item has one little ball in it. The next item has 3 little balls. The third has 6. I drew the fourth and I drew the fifth. So what we're trying to do with these is figure out how many are in the nth one. And so honestly, for this one, I had to do some sleuthing on the internet because I wasn't getting it. I found it in an old textbook and I was like, oh, I think I can figure this out. If I could draw up to the 10th figure, I could totally count them, right? But that's going to take a long time. So this one had a really interesting idea proposed. And once I caught on to it, it made sense. So it said, take these and double the number of dots. That's going to give us a rectangle that is our n multiplied by n plus 1. And that's going to give us twice as many dots as there are in this item. Let's take a look at this one. So for my second item, it would be 2 times 2 plus 1, which is 3, so that'd be 6, divided by 2. And that's how I get to 3 items in that, that individual thing, right, in the second in the series. Try this for the fifth. So if I were to sub in, oops, I'll go back to drawing, in the fifth item, I would have 5 times 6 divided by 2. That would give me 15. When I drew it and counted it, that's exactly what I got. So this is my conjecture. This is my pattern. And again, I think these are tricky. So take your time, convince yourself of them. Even when you have the answer, sometimes that there's still some logic implied. So in using my conjecture to determine the number of dots in the 10th figure, I would have 10 times 11, squaring out my triangle of dots, and divide that by 2 because I've actually doubled the number of dots. And so I get 52 little tiny dots in my, that's not right. 110 divided by 2. How about 55 small dots in my 10th item? So moving on to the next page, it gives us some number ones. And I'm going to stay with my answer key where the numbers are all written out because I think it speeds it up. You're going to take your own time with this. The next one in this initial kind of pattern recognition section of our unit is about number patterns. And this is a Pascal's triangle. So it was named after a mathematician. And the idea with this is you can develop this sort of series of numbers. So using inductive reasoning to complete the next two rows of Pascal's triangle, what I've done is taken and added the two numbers here. Do you see how I've added 1 and 6 to get 7? Or 6 and 15 to get my 21, right? 15 plus 20 is 35. That's how I'm completing this. I also started each row with a 1 and ended each row with a 1. So based on my observations and this process of completing the next two lines, I'm asking you to explain in words how you figured out the next rows. So basically what I said, and these are my words, your words might be different, the rows start and end with a 1. And as I add the two numbers from the previous row, you get the numbers in the next line. So see the arrows above, right? The other thing that I've noted here is that the rows are symmetrical. You'll notice that we've got an 8 and an 8 and a 28 and a 28 and a, you know what I mean, right? So they're symmetrical out from the center. And so that's another good way of checking your work as you go. The last one here, you can use a calculator for. So this might put people more in their happy place. And again, if you're like, whoa, I would not have got to these answers, it's okay. Just kind of, that's why I've given you the answer keys and I'm talking this through so you can kind of take your own time to get where you need to go. So this is my pattern here. 1 times 1 is 1, 11 times 11, 121. Take a look at this pattern. If we were to come up with the rule of what we see going on, we can see something where it begins and ends with the 1. And then it counts up to a number and then back to that number 1. The number in the middle here is how many ones are being multiplied. Do you see that? So if we have 5 ones multiplied by 5 ones, I'm going to count up to 5 and then back down to 1. If I have 7 ones multiplied together, I'm going to count up to 7 and back down to 1. Test these on a calculator. Mine worked out. So this is where I used my words. So basically what I'm doing is list the numbers, counting how many ones you see in the number, right? So counting up to 7. And then I make the answer by listing the numbers in a symmetrical format. So counting back down to 1. These might not be the words that you use to answer this, but this was my stab at trying to explain my thought processes in words. Sometimes you can get to the answer and you're not exactly sure why. You may be able to draw the 7th image in the series, but you can't come up with the, algebraic definition for the nth item. If you're getting anywhere, you're using logic and reasoning. So you're doing great.